Hello students, this video is about finding the interval where the y value is negative or where it's below the x-axis essentially. So what you need to know is this. In here is a coordinate 0 and that's 0, 0. That means x is 0 and y is 0. But above this line, all the all the y values are positive 1, positive 2, and so forth. Below is negative 1, negative 2, negative 3, and so forth. So where it's negative, it's going to be below that axis. So just keep in mind, we're looking for where the graph dips below the x-axis. So I'm going to put little arrows on the end so to go down forever. So this graph dips below the axis at these places. So we say that interval has beginning and ending points, right? Kind of like writing domain and range. So this interval is all the numbers that's basically to the left of positive 1. That looks to be positive 3. All the numbers to the left of positive 1. So that basically means it never stops going down to the left. It goes down to the left forever and ever and ever. It's going to go down. It can go down faster than it goes to the left, but it's going to go to the left forever. So for that reason, we say, see if I can make that go away. I don't really need this piece. So we say that the interval is from negative infinity to 1. And then union. It starts going down again at 3. It's below the x-axis again at 3. So we say it's again union 3 to infinity. That's the interval where the graph is below the x-axis. And that's the interval where y is negative. All right, of course you need more than one example to understand it, so I'm going to give you another one now. Okay, here's a new graph. Take a look at it. And you decide where you think that graph is below the x-axis. Well, if we took a good look at it, it's below the x-axis in this section of the graph, or the parabola. And we only use the x values when we're referring to these intervals. It's not like the range. We're only using the x values, so only using these numbers here. So that interval begins at negative 1, ends at positive 1. So my interval, it's going to look like an ordered pair, but that's okay. The interval is at negative 1 to 1 with soft brackets on each end, because you can't actually be negative at the actual 1 and negative 1, because there you actually are 0. So another thing I'll make sure I'm clear on is you need to use soft brackets whenever you talk about these intervals where the function is below the x-axis. Unless the function completely existed below the x-axis. I don't think you're going to see those though. So if the whole function is below the x-axis, well, it's different. All right, give you one last one. Okay, this is the final one. Take a good look at this graph. And I highlighted the vertex. Vertex is at 2, negative 1. And I highlighted the y-intercept just so you can think about those words again. But ultimately, I want you to determine what interval is this graph negative on? What is the interval this graph is negative on? Think about it for a second and write it down. And then if you're right, you're good to go to the next lesson. Oh, pause the video, or you're going to hear me answering the question. So pause it now. All right, so if you answer the question, you should have got the interval that was negative was on positive 1 to 3, because that's the interval with the graph below the axis. So the interval is negative, is positive 1 to 3 with soft brackets. So negative on the interval (1 to 3). I want to make sure I wrote it out because you might see it again on the test, and I don't want you to see this word interval and think, I don't know what that word is. So saying it is one thing, but seeing is another. So that's it. That's how I determine whether or not a function is negative along an interval or not. I always use x values in the intervals, and unless the graph is completely below the below the x-axis, then the interval should have soft brackets on the end where it hits the x-axis. That's all I have. Good luck.